Triangle congruence, proving triangles congruent, ASA and AAS. Alrighty then, let's Lesson 4.4, proving and applying the ASA and AAS congruence criteria. Prove two triangles are congruent using ASA and AAS criteria and apply to solve problems. Prove that two polygons, all of whose corresponding sides and angles are congruent. Apply congruence criteria to increasingly intricate problems involving overlapping triangles and multiple triangles. Mastery Connect warm-up number 1. The measure of the vertex angle of isosceles triangle ABC. Yes, we've already covered isosceles triangles. Is x plus 15. The measure of each base angle of triangle ABC is 2x minus 10. What is the measure of the vertex angle? Let's draw a little picture. Here we go. Vertex angle, I'm going to call A. Base angles are B and C. Vertex angle, they said, was x plus 15. The base angles are both 2x minus 10. Now remember, all three angles of a triangle add up to 180. We need to find the measure of the vertex angle. Big question mark there. So add them all up. X plus 15 plus 2x minus 10 plus another 2x minus 10 equals 180. Combine like terms. Actually, let's just get rid of the parentheses first and then combine like terms. All right, 5x minus 5 equals 180. Add 5 to both sides of the equation. 5x equals 180. 5, divide both sides by 5, and x is 37. Yes, that's an option. No, that's not the final answer, because we want the measure of the vertex angle of triangle ABC. So angle A there. So we need to plug in the x that we found into the expression, x plus 15, and our answer is 52. Careful. Make sure you always pay attention to what you're actually finally looking for. Mastery Connect, warm up number 2. What's the measure of the smallest angle in the right triangle? That looks like the smaller angle, larger angle. Of course, the largest angle is a right angle. And the two acute angles of a right triangle are indeed complementary. They add up to 90. So 2x plus x plus 6 equals 90. Combine like terms. 3x plus 6 equals 90. Subtract 6 from both sides of the equation. 3x equals 84. Divide both sides by 3. X is 28. Is that what we want? No, but it's not an option there to trip you up. We need the smaller angle. So there's our smaller angle, x plus 6. Throw in the 28 in place of x, or substitute. Combine the terms, simplify that, we get 34 degrees. Warm up number 3. Determine which postulate can be used to prove that the triangles are congruent. If it's not possible to prove congruence, choose not possible. That definitely looks like SAS. Warm up number 4. Same directions. Shared side, always congruent. SSS. Let's see. No more information. It can't be SSS because we don't have all three pairs of sides. SAS, the angle's not in between the sides. So it's got to be C. Not possible. Determine which postulate can be used. Same direction, shared side, SSS. Again, warm up 7, SSS. Everything's marked for for us. Congruent triangles, ASA, new method. Angle side angle congruence theorem. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Included means the side between the angles. There's a little diagram for you. If angle A is congruent to angle D and the side segment AB is congruent to segment DE and a set of angles so that the sides in between the angles, angle B is congruent to angle C, then the triangles are congruent using ASA Congruence Theorem. Triangle ABC is congruent to triangle DEF. Here's a proof. Yes, it's okay. We'll do the proof. So segment SQ bisects angle RQT and RST. Given. There it is, our bisector. It's bisecting this angle. So those two angles are congruent. That is definition of angle bisector. It also tells us this angle, RST, is bisected by that same segment. I drew a line, doesn't matter. Definition of angle bisector, and of course we have our shared side reflexive property. And there we go. We have two sets of angles. The side is in between. So it's angle, side, angle, congruence theorem. Another proof. Complete the given proof. Number 2. Segment JK is parallel to segment LM. Marked it with green arrows. Segment JL is parallel to segment KM. Marked it with purple arrows instead of doing double arrows. Okay, we can figure this out. That is given. Angle JKL, look on the diagram as you read the name, is congruent to angle MLK. Those two angles. Those are alternate interior angles. And if the lines are parallel, then alternate interior angles are congruent. That's the theorem. Another set of angles congruent. Angle JLK is congruent to angle MKL. Look on the diagram as you read it. That's those two. Instead of double arcs, I did a different color. So that pair of angles are congruent. Those are also alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Shared side, reflexive properties. Segment KL is congruent to segment LK. Same segment, you can name it in either direction. So it is the same segment. So if you look on the picture, two sets of angles, sides in between. Angle, side, angle congruence theorem is what was used to prove triangle JKL congruent to triangle MLK. Proof number 3. We are given angle BAC. Look at it on the picture as I say it and as you read it. Is congruent to angle DEC. Mark those green. C is the midpoint of segment AB. It only says it's a midpoint of one of those segments that goes through it. But that means those two are congruent. So reason number 3, segment AC is congruent to segment CE by definition of midpoint. Look at the next statement. Statement number 4, angle BCA, look at it on your diagram, is congruent to angle DCE. That's those two. Those are vertical angles. Everything from day one's fair game. That's early on in the course. So vertical angle theorem. So look at your diagram. Two sets of angles, sides in between. ASA Congruence Theorem proves triangle ABC is congruent to triangle EDC. Congruent triangle proofs, again, different method. Angle, angle, side. So two sets of angles again, sides not in between. If two angles and the non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. Non-included means it's not between the angles. There's a little diagram to show you, but we also have it there in our layout to explain the theorem. So angle A is congruent to angle D, one set of angles. Angle B is congruent to angle C, second set of angles. And then we have a pair of sides that are not included. So segment BC congruent to segment EF. Then the triangles are indeed congruent using angle, angle, side theorem. Triangle ABC is congruent to triangle DEF. Now, instead of the pair, segment BC being congruent to segment EF, we could have used the other pair, segment AC congruent to segment DF, because it's still not between the angles and their corresponding sides. Okay, let's go. Complete this proof. We are given, and the given's already marked there, segment YZ bisects an angle, angle WYX. Look at it as I say it on the diagram. There we go. That's an angle bisector of that angle. We also know angle YWZ is congruent to angle YXZ. Mark those. Didn't mark the other ones. Okay, so all the givens in are proof. Now it says angle WYZ is congruent to angle XYZ. That was given. There we go. One arcs, but different colors. Okay. Does not mean they're congruent to the other set of marked angles. But that's by definition of angle bisector. And we do have that shared side reflexive property. Segment YZ is congruent to itself. Segment YZ, reflexive property of congruence. And then by angle, angle, side, congruence theorem, the set of sides that are congruent are not between the angles, and they are corresponding sides. Number 5, another proof, angle ABC. Look at it on the picture. Is congruent to angle CED. There we have it. It's given. I marked it in the diagram. Parallel. Segment AB is parallel to segment CE. Marked it with arrows. That's given. The next statement in the proof, because so far they just put the two givens, angle BAC is congruent to angle ECT. That's those angles there. And because of the parallel lines, those are corresponding angles. So corresponding angles postulate. If the lines are parallel, then corresponding angles are congruent. It's not the converse because we are starting with parallel, not ending with parallel. C is the midpoint, another part of what is given. There it is. And if it is the midpoint, then we know those two segments are congruent, and that is step 5. Segment AC is congruent to segment CD. That is by definition of midpoint. And if you look at the picture, we have two pairs of angles, one pair of sides. Sides are not between the angles and their corresponding parts. So angle, angle, side, congruence theorem. Mastery Connect example. The figure shows two triangles. Triangle ABC, the left side, and triangle ADC, the right side. In the figure, segment AC bisects both angle DAB and angle DCB. Okay, so that bisects them. An angle bisector divides an angle into two congruent angles, so I'm marking those for us. Of course, we have a shared side. Side is between the angles, so that is angle, side, angle. Mastery Connect number 2. All we need is the statement for the reflexive property. So look on the diagram. Which segment is reflexive property? And that's got to be the shared side right there. Segment PS congruent to segment PS. Mastery Connect example number 3 in the figure below. Segment PQ, look at it on the diagram, is congruent to segment RQ. Marked it. Segment PS is congruent to segment RS. Marked it. Of course, they have the shared side. SSS is what it's looking like. Side, side, side can be used to prove triangle PQS similar. Oops, congruent to triangle RQS. Mastery Connect example number 4. Everything's already marked. Those two triangles are shown. Which theorem can be used to prove triangle MNO congruent to triangle RST? Sides between two pairs of angles. So that's going to be angle, side, angle.